Alrighty, so next topic, finding if a question can be answered by the data. Not all questions can be answered by the data, even if the data is related. For example, each student in Miss Alvarez's class is either a junior or a senior. All right, that's it. And nobody can be both. Ms. Alvarez has 47 students in her class, 32 of whom are seniors. Recently, she took some of the students from her class on a field trip. Of the 32 seniors in the class, 7/8 went on the trip. So let's see what we got here. How many seniors from the class went on the trip? Well, it said that 7/8 of 32 students went on the trip. So 28 students. You can cancel the eights there and get the 28. Okay. Part B, how many seniors in the class did not go on the field trip? Well, of the 32 seniors, 28 did go, leaving 4 who did not. Okay. And the last one, how many juniors from the class did not go on the field trip? Well, we can tell there are 15 juniors, but we don't know how many went and how many didn't go. So for that one, we would say not enough information. We just can't know. We know the answer is between 0 and 15, but that doesn't really answer the question, of course. Okay, now let's get back to understanding the mean. So this is kind of a different approach for talking about the mean. So the graph below shows 2 black bars. Glad it said it was black because if I move my head a little, my colorblind eyes tell me it might be tinged with red. Okay, adjust the light bar, so this guy down here, so that it has the mean height of the 2 black bars. Well, mean means average. Okay, just dead center. Well, yeah, it's kind of like saying, on average, how many runs did this baseball player get? Well, when you talk about that, you're not talking about the most that he gets or the least. You're talking about somewhere in the middle. All right, is that the middle? Let's see, is 2, can we adjust these? No, okay. So this bar is now 2 higher than the little one and 1, 2, 3, 4 lower than this one. So it's not right in the middle. If I go up 1 more, now it's 3 smaller than the big one and 3 bigger than the small one. So yeah, it's right in the middle. That would be it. And that's all you got to do. But that's for finding the mean, or in other words, the average. All right, on this one, we're doing the same thing again, except now we've got 4. We have more than 2 bars. So it might be just a little trickier. Well, again, this bar is supposed to be in the middle. So that looks like maybe the answer there. Tell you what we could do. We could say, you know what? Let's see. This would be 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13. Okay, so how tall are each of these? Well, the first one looks like it's height 9, and the second one, therefore 10. The next one is up 2 from that, and the last one is up 1 from that. And so when it says go find the mean, again, that means average. You could just say, well, let's just add them up and then divide by how many you add together. Let's see, so that would be 25, 35, 44, which will be 11. So we would just need to make sure that our bar is at height 11, and there it is, which is really close to what I estimated in the first place. So that would be it. I'll check it, and it's correct. Okay, and that would be one way to do it. A really, just a nice simple way. Okay, so now we're going to find the mean again, the average, except this time, instead of being given a bar graph or a histogram, we're given basically the same thing, except some people will call this a dot plot, where you just have all these X's instead of bars. But it's really basically the same thing. It's like saying, okay, well, one bar is there, and another bar is there, and so on. Okay, and you can just use those x's instead of bars. So yeah, not a big deal. Now, and then clearly the number of x's tells you how often things occurred. So if we say, hey, I got a whole bunch of friends who have M&Ms. Well, how many people had 3 M&Ms? Well, one person had 3 M&Ms. How many people had 4 M&Ms? 3 people had 4 M&Ms. And 3 people had 5 M&Ms, and one person had 6 M&Ms. I mean, so you could kind of think about it, like that. Okay, so now one thing that they do give us that really helps on this is they made sure that the distributions were symmetric, and it says that in the name of the topic. So if you split it down the middle, okay, then both sides are going to be a mirror images of each other. So what would be the mean or the average, or in other words, the number right in the middle? Well, right in the middle is right where I drew the line. For the first one, that's going to be 4.5. And for the second one, looks like it's hitting right at 3. Okay. And so that would be how to do it. It's not hard, but if you haven't seen it before, it might not be obvious at first. Okay, on this one, computations involving the mean, sample size, and sum of a data set. It's not exactly how I would have described this type of a problem, but it still suffices. So it says Rachel drove a total 784 miles over a few days. She drove a mean distance, an average distance of 56 miles per day. So, one day maybe she drove 55, another day maybe she drove 57, and so on. But it averages out to 56. Okay. I don't even know why I'm erasing that. Okay. So, so over how many days did she drive? So if every day was an average of 56 miles per day, then we can just assume that every day was 56 for the sake of what we're looking for. And so we could just say, oh, okay, let's take the total amount and chop it up into 56-mile increments, and that'll be 14 of those 56-mile increments, 14 days. Okay. And that's all we got to do. That is it. Okay, so finding the value for a new score that will yield a given mean. Jim's participating in a 5-day cross-country biking challenge. He biked for 56, 70, 57, and 53 miles on the first 2 days. So how many miles does he need to bike on the last day so that his average, his mean, is 57 miles per day? That's really close to the one from the last problem, which means nothing. Okay, so let's okay, so this one's not especially difficult, but a lot of people at first will get it wrong. They'll say, they might say, all right, so the mean or average, this is the symbol for average or mean. The mean, let's see, 56 plus 70 plus 57 plus 53, okay, for 5 days. And then you say, and then they go and they figure it out and they get an answer. And you know what? I'm just going to go get that answer real quick. Let's see if I can type it. Okay, and I get 47.2. Seems a little low. I mean, that seems really low for this. So what's the problem? Well, here's the problem. We only added 4 days together, and if you're going to find the average, you got to divide by 4 if you're doing 4 days. But we're not doing 4 days. We're doing 5 days, and we're looking for what the We're looking for what that last day needs to be. So whatever you're looking for, just call it a variable, okay? Or whoops. And well, we know what the mean is. We know what it's supposed to be. It's supposed to be 57 because it said so right there. Now we have an equation that we can solve. All right. So first thing, let's add that stuff up on top. Okay. Let's see. I don't know. Is this the color I was using? Nope. Oh, well, doesn't matter. Okay. So I add those up and I get 236 plus x over 5. So notice I'm saying first day, second day, third day, fourth day, fifth day. I don't know what the fifth day is, but it's still one of the days. And now I'm adding 5 things together. So I divide by 5. And so, yeah, so what I'm doing makes sense. All right. So now let's multiply away that denominator because it would be really cool to not have fractions, wouldn't it? That would just be so cool. All right, so then we'll have 236 plus x. And I better just multiply that in my head. I don't want to get it wrong for the video. Okay, 285. Did I say multiply in my head? I meant on the calculator. Okay, and then not much left to do. I'll take away 236. And I'll keep changing my color because I'm colorblind, and so it's cool. And okay, 49. Actually, not that far off from that wrong answer we had, huh? Usually it's further off, but yeah, so 49 miles. That is what's going to be our answer. Okay. So again, we want the average. If you think about it, we want the average to be 57. Well, that one is right on the average. This guy is pretty much right on it. 53 isn't that far away, but you do have this 70 that's significantly higher than the average. And so if you want to stay, if you want to stay around 57, you have this pretty high number, you're going to have this number that's significantly lower. So that everything averages out to 57.